solution to y is greater than x minus 3. So to determine if something is a solution, you're simply going to take 5 and you're going to plug it in for x. You're going to take 2 and plug it in for y. Now you guys had done that earlier in the year when you tested your solutions to equations. You would get x equals 4 and you would plug it in. We're going to do the same thing here now, only we have an x, comma y. So what is 5 minus 3? 2. Is 2 greater than 2? No. So because that's false, we say no, it's not a solution. So I know now that 5, 2 would not be part of my shading when I graph that line. Now we're not asking you to graph here, but that at least tells me 5, 2 can't be shaded in. Let's take a look at number 2. How am I going to check to see if that's a solution? Ethan?
One plug in 3 for y, 1 for x, subtract, get 2, and the answer is yes. It is what it is.
We all agree that 2 is less than or equal to 4? So we would say yes. So I think you guys have like 3 or 4 problems in today's assignment that start out that way. All right? So any questions on how we're testing these points? Beautiful, because ladies and gentlemen, that's what we're going to do every time we graph. We're going to test a point. All right, to determine if it's a solution. Now, we're going to give you an easy point to test. We're going to try and make the math very easy for you guys. All right, so let's take a look. To graph inequalities, you're going to graph the boundary lines. So remember to graph a line using slope and y-intercept. We haven't done stuff with x and y-intercepts in a while, guys. So we're going to stick with y equals mx plus b, okay? We're going to stick with that for tonight. You're going to use a dash line when it's just less than or greater than. Think about those open and closed circles, okay? If it would be an open circle, then we would keep it as an open line, something with a dash. If it's going to be a closed circle with the equals to, we use the solid line, all right? So while you're doing your homework tonight, ladies and gentlemen, keep your notes out to know whether we're going open or closed. Are those assignments? I'll do those later. Sorry. We then need to test a point not on the boundary line in the original equation. And so what we're going to do is we're going to test something similar to what we just did here in the first 2 examples. So we could test 5, 2, we could test 1, 3. But I'd like to make it pretty easy. So what I'm going to do is test 0, 0. I want to see whether 0, 0 is a solution. And if it is, then I'll shade that side of the line. If you don't have 0, 0 written down, I'd get it written down now. If 0, 0 isn't a solution, then I'm going to have to jump to the other side of the line. Okay, guys? Because we saw that with that first example, either the answers worked and they were all in red, or they were in black, or blue, I think was the color I used, and they didn't work. So let's take a look. We need to graph these, so we're going to go through. Oh no. Never mind. I know. Well, this one I did use an x and y intercept, so we're going to have to get rid of that one.
Is this the on your own?
No, this isn't the on your own one. This is the first. This is the first example here, isn't it? All right. So ladies and gentlemen, we're going to solve for y. How are we going to solve this equation for y? We're going to minus the 4x. So we'll minus 4x from each side. And then what am I going to have to do to finish that up? Divide by -2. Now I heard someone ask, do I have to flip the inequality? I'm having the same conversation with my juniors. It has nothing to do with what lesson we're on in the book, ladies and gentlemen. It has to do with inequalities. Every time we have an inequality, if I divide by a negative, I have to reverse that inequality. So I'm going to have y is greater than -2 plus 2x. my graph at according to my equation? -2. And then what am I going to do with that 2 from my slope? I'm going to go up 2, and Darlene, how many will I go over? Good job. So we'll go up 2 over 1. Up 2 over 1. We're going to take this all the way across our paper, guys. Now I need to notice I made a bunch of dots. I haven't done any connecting. I haven't drawn anything in because I need to know whether it's a solid or a dashed line. Alex, is it going to be solid or dashed? How do we determine that? No, they're all going to be straight lines. Nothing's going to be jagged. So I should go back up to the beginning. It said it's going to be a dashed line if it's just less than or greater than. So this needs to be highlighted. Some of you need to circle this now. Solid line for less than or equal to or greater than or equal to. So what does example 1 have, Alex? Or Alex? Less than and equal to or just less than? What does example 1 have? Less than or equal to? So is it going to be a solid or a dashed line? Thank you. So we've got our dashed line. What we need to do now, ladies and gentlemen, is we need to figure out which side we're going to shade on. So we said we were going to test a point. What point did I tell you guys to write down? 0, 0. The nice thing about 0, 0, ladies and gentlemen, is if I plug it into the original equation, if I plug it into this equation, -2y plus 4x is less than 4, when I plug that 0 in, I get -2 times 0. I then have plus 4 times 0. And then I have less than 4. Guess what's going to happen to that entire left-hand side, guys, when we multiply everything by 0? It becomes 0. So I get 0 plus 0. And what's 0 plus 0? 0. Do you see why that 0, 0 is such an important number to write down, guys? Because it's going to make your math pretty easy. And it's really easy to compare numbers to 0. Is 0 less than a positive 4? Yeah. So because 0, 0 is true, this is the point that works. Guess where my shading is going to go? On the top of the line. All right, so let's take a look at the next one. Do I have to do any work with this equation? No, I've got y by itself. It's good to go. So let's see what happens when I move my purple box. So we're going to graph using slope and y-intercept. Do we agree to plot 9 on the y-axis? All right, so we're going to start at 9. And then my slope is negative, so I'm going to count down 2 over 3 to the right. Make sure you do a positive move there. So you're going to go down 2 over 3. And I'm going to keep going with that down 2 over 3 till I kind of make it off my graph paper. Now notice I just have dots. They all made a straight line, and they're going to, guys. If your points don't line up, then you know you've graphed something wrong. But I need to know whether I'm connecting those points with a solid line or with a dashed line. So Philip, am I connecting it with a solid or a dash? Solid, because I'm equal to. Good job. All right, I'm connecting it with that solid line. All right. So we connect to the solid line that's equal to. And then guess what we're going to test next, ladies and gentlemen? I'm going to test 0, 0. Now this one, when you plug 0, 0 in, guys, we don't have everything on one side being 0, do we? But we have this 0 plugged in for y. We have 0 plugged in for x. What's negative 2/3 times 0? 0. So does that term basically disappear? And so what am I left with? 9. Now when you tested 0, 0 here, we get a false statement. And so what that means is 0, 0 doesn't work. So if 0, 0 doesn't work, nothing on this side is going to work. So where am I going to have to shade at? I'm going to have to shade above. All right. Any questions, ladies and gentlemen? All right. How am I going to finish up the third one on the back side? What are we going to do with that one? Darlene? Beautiful. Minus the 3 from each side to get x by itself. But now this x is greater than 6 should go just like our example problems, correct? Vertical or a horizontal line? Davis has got his hand up like this. I'm assuming you're making the vertical symbol with that. Yep. All right, so vertical line at 6. Solid or dashed? Am I equal to? So I can't fill it in, so it's going to be a dashed line. And I need x is greater than 6. So guys, even though this is the point 0, 0, I can still just plug 0 in for x. Is 0 greater than 6? No way. 0 can't be greater than a positive, right?
Do we need to put that up?
No, you don't have to. But because 0, 0 is false, I have to shade on the other side. Now, ladies and gentlemen, how many of you already knew which direction you were going to shade? Is the inequality pointing you? Good job. Oops, someone said wait. Oh, maybe not to me. All right, what do we do with that last one? Negative 3y is less than or equal to negative 8. Divide by negative, well, be careful. Let's divide by negative 3. So what's going to happen when I divide by negative 3? I have to flip the inequality. And so what is negative 18 divided by negative 3? 6. Horizontal line, correct?
Solid line.
I went with solid. Why? Because it has the or equal to. Good job. I need to be greater than 6, correct, guys? Is 7 greater than 6 or 5 greater than 6? 7. So you can test it that way. Or, guys, if you plug in 0, you're going to get a false statement, so you know it doesn't work. So we can fall back on our testing for those horizontal and vertical lines, or just kind of use our common sense. Now, I do believe if I switch, it's an on your own. So it says, bring it up to me. I want you guys to raise your hand, and once your hand is in the air, I will hand you a piece of graph paper. And once you have a piece of graph paper, that means you get to start on tonight's assignment. I think we get like 2/5 or 2/3. No.
Yeah, my dog.
Yeah, and then divide by the y. Yeah.
Definitely is 9 over 4.
Hold on, let me see this other side. Oh,
I'm getting my pen.
hold on, I'm shading the other side.
Oh, John, you're Jack, did I give you a red graph?
I did.
Oh, I got you.
7. Thank you.
Okay,
No, I'm sorry. So, here's the 4.5.
no, it's like a double.
Over the 4.5 now.
No, you guys have to get your agendas out. I don't have the homework out there.
Oh, mommy.